What's up, guys? Today we're here for another video, and today you might hear a little echo in the background because I am in a different, completely space right now. I'm not even at home, so go Aggies, go A&M. So that's where I'm at right now. But I had to make this video because it's probably one of the most important topics ever in all of math. So hopefully I'm waking anyone up. It's around I think 12. It's about to be 12. So hopefully everyone is asleep. But yeah, so we're gonna start with the unit circle. And just like in the other video, I proved the identity of sine squared theta. Theta is just another, fancy thing for x, plus cosine squared theta is equal to 1. So you might have been wondering, what is the unit circle exactly? So the unit circle is essentially just a circle that is radius 1 and it has different endpoints. So if you were really good at geometry class, you'll remember that the circumference of a circle is equal to 2 pi. So that would be circumference. And so from here we have different radians, aka also called other parts of the circle. So you have 0 radians here, pi half radians here, pi radians, and then you have 3 pi half radians to represent, different parts of the circle as well. And so in the middle you would have pi third, pi half, and pi 6. I'm sorry, not pi half, pi 4. And so this trend continues. So next to pi half, you will have 2 pi third, 3 pi 4, and 5 pi 6. Until you reach pi, then you have 7 pi 6, 5 pi 4, and you have 4 pi 3. Then from here, you will have 5 pi 3, 7 pi 4, then you will get 11 pi 6. And so as you can see here, you can see the trend and continuing patterns. So you can see how like we're increasing the radian every time we get closer and closer. And at the end, you'll just have a full circle at 2 pi. So that'll be your whole circumference. And so when we talk about the unit circle, we're not talking about just the radians, but we're also talking about the degrees. So each of these different points of the unit circle have different degrees in them. So the pi 6 will be 30, pi 4 would be 45, pi 30 will be 60, then we skip 90 degrees over to pi half, which is 90. Then from there we just add 15 again, 105, 120, 135, and then from here, I'm sorry, you don't do that. You add 30 degrees again, so this would be 120, 135, this would be 150, add 5 pi 6, and then pi would be 180 degrees. Then you just keep going the trend. 180 plus 30 is 210, 225, 240, you add 30 more degrees, then you have 270 degrees. Continue doing the trend, 300, 315, 330, add 30 more degrees, then you'll get to a full circle of 360 degrees. And so how we measure out the points of the unit circle. So those are just like the radians and the degrees of the unit circle. But to actually measure out their points, what we do is essentially we draw the unit circle again. And then this time we have to acknowledge the fact that the unit circle is essentially just a circle on an x and y axis with a radius of 1. So that means from here to the center, it's 1. From here, it's 1. From here, it's 1. And from here, it's 1. Don't do that. And so then from here, we can safely assume that the points on 0 or 2 pi, pi half, pi, and 3 pi half, their respective points would be 1, 0, 0, 1, negative 1, 0, and then 0, negative 1. And so essentially all of these different points also have points in the middle. So just like how we have the radians and the degrees, you also have to remember the points that come with the different degrees. So if you're good at pattern recognition at pi 6, and so essentially the whole idea is that you're just making a right triangle. And we can see here that the vertical so essentially the whole idea is to just like make a triangle, you know, because you have to acknowledge the fact that sine squared theta plus cosine squared theta is equal to 1. So from here, the respective points for each of these radians or degrees is as following. So for pi 6, it's root 3 over 2, 1 half. For pi 4, it would just be root 2 over 2, and then root 2 over 2. And then for pi third, it would just be the opposite of pi 6. And then from here, you already know it's just 0, 1. Then for 2 pi third, it's actually the opposite of pi third because as you can see here, we're in the left side of the y-axis. Therefore, the x is negative, so you have to change it to a negative. Same goes for 3.4. And same goes for 5 by 6. And then from here, we can acknowledge the fact that this is negative 1, 0. And then since we're in the third quadrant now, because remember 1, 2, 3, 4 counterclockwise. Since we're in the third quadrant now, this means that it's all negative. Because as we can see here, the x is negative and the y is negative. So from here, it's just really a simple pattern. So for 7 pi 6, it's the same, just everything's negative. And then it's the same for 5 pi 4. And it's the same for 4 pi 3. And then from here, we just left with 0, negative 1. And then from here, since we're on the right side, we can say that the x point is positive, but the y point will be negative because we're under the x-axis or under 0. So from here, since this is 5 pi 3, we would say that it's 1 half negative root 3 over 2, root 2 over 2, negative root 2, and then negative root 3 over 2. Oh, I'm sorry, just root 3 over 2, negative 1 half. And so from here, I actually have a little acronym that my calculus teacher told me about. So the little acronym is all students take calculus. So essentially what this means is that when you're trying to design, you know, and before I get into this, I have to tell you that sine is equal to the y coordinate and cosine is equal to the x coordinate. And so what this means is essentially that when we looked at the different quadrants of the unit circle, in the first quadrant, everything is positive. In the second, the y is negative. In the third quadrant, it stands for tangent, and you'll see why. But in the T or in the take, everything is negative. Even in the C section, cosine is only negative. And you can see why when we go back to the circle. Oh my God, I'm so sorry. Not that we're trying to find for the negative, but that we're trying to find if it's positive. And so I'm sorry for my mishap, but here in the A, everything is positive, and the sign is only positive, or the y coordinate. T, everything is negative. Like it doesn't matter, everything is negative. Except for tangent, and you'll see why. And then for C, only cosine is positive. And so essentially what we have to do is that we have to recognize the inverse functions as well for sine and for sine x. So when I mean by tangent, what I mean by that is when you're doing tangent x, it's just sine x over cosine x. So essentially how you want to map out the diagrams is that whenever someone tells you, to remember like, simple points. So let's say someone told you what sine of pi 3 was. You would just go back to your unit circle, remember it, and you just go like, well, sine of pi 3 is just a y coordinate. Therefore, since the x is bigger, we can safely assume that the sine of pi 3 is just root 3 over 2. And it's the same thing when you do cosine of pi 3, because it's just 1/2. And so essentially that's just like a quick intro. Actually, let me show you a tangent. So let's say you have tangent of pi fourth. Since it's just sine x over cosine x, you just do root 2 over 2 over root 2 over 2. And then you just do keep change flip. And they just cancel it out to be 1. So essentially when someone talks about the unit circle, this is the main thing that we're talking about. This is just an introduction video. Obviously I didn't get into too depth, and I'm scared that someone else is gonna hear me and make fun of me for recording this YouTube video here. But essentially this is just like a quick introduction to get you used to the unit circle. Or as a quick refresher. It's literally just a circle with one radii, and then from there you just use it to map out different points. Because the angles are unique to every single triangle, which is what we're trying to make, remember? We're trying to make triangles, which is what we're trying to make here. So essentially that's just a way to, remember the unit circle, the points. Hopefully y'all found this video very, very helpful. Obviously I did make a lot of mistakes because I am scared someone's gonna hear me. But hopefully I enjoyed. Thank you for watching, and goodbye.